First thing about the SQL, right? It will have almost what I should say, approximately 30% advantage, right, in the interviews. So this thing I want to clear to each and everyone, that doesn't matter, or if you think that okay, you are the data engineer and for you SQL might not play that much important role in the interviews. So this is not true, because uh, when it comes to build the data pipelines, time to time you will be working with different type of transactional databases and the NoSQL databases, and sometimes the data warehouses as well. Okay, so in that case, definitely this is pretty much needed, and most of the time you will be following that syntax, right? Whatever you want to, you can say, let's say you have a different type of databases, to in order to access the data, manipulate it, you need the SQL, right? You need to write the SQL queries. So the way we write the programming, right, the way we use the Python language or any other programming language, let's say you have to join the two numbers, you have to take the sum of two numbers programmatically, so you will be writing the code Python program for that. Similarly, when we talk about the big data and in terms of the data, so obviously first it will get stored somewhere, right? And you can assume the databases for that one. And in order to query that, right, you need to follow some specific syntax and some sort of query language. So that is your SQL, right? So SQL basically stands for your structured query language. Okay. And now coming to this part. So before going into the SQL part, like how to write the specific syntaxes of it, you need to understand the difference, right? You need to know about some very basic terminologies, right? So we'll get started with those terminologies. So first terminology is the, you can say, database, right? So first we'll talk about the database, and after that RDBMS tables, right? All those things we will quickly talk about it. So database basically it is the collection of data in structured, in some specific structure. Okay. So databases, when we talk about it, so you need to consider them as the applications, right? They are like other software application, which basically helps you to store the data in some specific format, right? And when we talk about the format, when we talk about the data, and that is the part where the categorization starts, right? So you will, time to time you will hear about the transactional databases, right? You will hear about those databases which stores data in the raw format, right? And apart from that, there will be databases which stores the data in the partition form, in the columnar storage. Few databases which stores the data in the, you can say, graph format, right? Hierarchical sort of dependency they follow. Okay, so there are different types of it. Okay, so database, the simple definition is it is the collection of data in some specific format, right? And you need to consider them like another applications, like another software application. They are not, don't consider them like a server or some machine which just lets you store some data, right? It is another application which runs on some particular environment and lets you store that data. Okay. So after the databases, let's talk about the uh, type of it, right? Let's quickly talk about the type of it. Okay. So majorly it is categorized in two parts. Okay. First is going to be your transactional databases. And second category is your NoSQL database. Okay. And being a data engineer, this is going to be your core expertise, right? You will be working with the transactional databases heavily. You will be working with the NoSQL databases heavily, right? When you build the pipeline, there can be n number of data sources. There could be a number of destination of different types. Okay. And on the other hand, when it comes to maybe let's say data analyst or something, they might be only working on the query part, right? Just querying the data, not maybe on the engineering aspect of scalability, optimization, and all those things, because their task is just to get the insights from the data. Okay. So when we talk about the transactional databases, right, what is the main purpose of it and what are the different examples of it? So here you will see different type of you can say databases like MySQL, Postgres, right, Oracle, and MS SQL, right? So these type of different transactional databases example you'll keep on seeing. On the other hand, you have the NoSQL databases like MongoDB, and we will be going through with the MongoDB as well. We have Cassandra, right? And similarly, we have different cloud-based NoSQL databases like the DynamoDB, okay? And apart from that, different categories, right? You will see Elasticsearch here, right? And ScyllaDB, many other, right? Neo4j, tons of, right? Very different example. And here there will be one very important core concept, right? Because when it comes to the design part, when it comes to the architecture part of your data pipelining, then deciding factor, right, means how we can decide that this particular database is a good fit for our you can say architecture, because these NoSQL databases are of different type. Like MongoDB is a document based, right? The entire data in the JSON form, you can simply dump it there. On the other hand, Cassandra works in the columnar form, right? And apart from that, Neo4j, this is basically stores the data in the hierarchical form, right? Some graph type of connectivity you will see among the data points. Okay. So depends what type of use case you are solving. And NoSQL databases, their primarily purpose in the data engineering, you can say, first of all, they are distributed, right? They are horizontally scalable, right? Horizontally scalable means today you are dealing with 100 GB of data, right? Let's say, and maybe after 2 days, there is huge traffic on your website platform and it is generating more amount of data. So in that case, you need to scale your system. Means by the time you created your basic setup, the only capacity of your database was to store the 100 GB, but now you had to, let's say, store 1 TB. So what you will simply do, you will add more machines into it, right? And that is what your horizontal scaling is. Okay. When you are adding more and more machine, and we will again deep dive into these important concepts when we will start with the Hadoop and big data fundamentals, right? So don't worry about it. Here I'm just talking about as a reference and you can understand it, right? When you are increasing the capacity of the large cluster by adding more machines, okay, that is your horizontal scalability. So NoSQL databases can do that, and hence, right, they can be the good fit for any large scale big data use case. Apart from that, they are distributed, because when you talk about the big data, parallelization, parallel computing becomes the most important part, right? So these databases supports that one. And apart from that, these NoSQL databases, you can consider them uh, like they are good fit to solve any obviously big data related application where you are expected to where you are expecting faster read and write operation plus the data analytics on top of it, right? So faster read write operation plus data analytics, and how you are going to decide among these NoSQL databases of different categories which one is a good fit for you. And this is the part where cap theorem will play a important role, right? So NoSQL databases, and apart from that, this cap theorem also covers the transactional databases part as well. So when we will start with the NoSQL databases, we will read about this theorem and we will deep dive into it. But this is a very important factor, so you also can look into it. So based on the cap theorem, we will be deciding, right, which particular database, even NoSQL or transactional, both, right? This can be a decision making factor if you are stuck with any specific problem statement that, okay, I have different database. So just understand your use case and try to map it with the cap theorem, right? Draw a Venn diagram and just figure out, okay, what could be the possible example or could be the possible database type which you can pick. After that, more factors will come into picture, like the costing part, scalability, and apart from the integration of that particular database with the, let's say, cloud services or within your system, all other factors will come into picture, right? So obviously our node SQL database is the part of later module. So now let's talk a bit about the transactional databases, right? And the RDBMS. All right. Let me add. Okay. Just a moment. Transactional databases. Right. So when we talk about the transactional databases, so here their main properties, right, are going to be vertically scalable, right? What is vertically scalable? We'll talk about it. Acid properties, right? They have to follow the acid properties. Uh, Use cases where data consistency is the primary factor. Apart from that, acid properties, use cases where data consistency is the primary factor. And one more thing. Yep. So apart from that, the read write part. Okay. So faster read and write operation, not used for heavy data analytical queries, right? Why I'm talking about it? Because you will be encountering these type of questions, right, in your data pipeline design, because these type of questions will be the deciding factor for you why you should go for this database or not. And even the interviewer can also ask it, right? What are the main properties of your transactional databases? Why you are going to go for it? So one thing I talked about it, when you talk, so vertically scalable. So when we were talking about the NoSQL databases, they were like your horizontally scalable. But vertically scalability means you have one specific machine and you are increasing the capacity of it, right? Earlier, let's say you had a machine who had 8 GB of RAM and some 500 GB of hard disk. Okay. Now, if you just increase the capacity of one single machine from 8 GB, you are making it like 16 GB, okay, and maybe 1 TB of hard disk, something, right? So in that case, what you did, you increase the capacity of one single machine. And now, can anyone tell me that if we have one particular specific machine, right? So can we increase its capacity beyond some specific point of time, right? Can we add infinite number of RAM to that particular machine? We cannot, right? If anyone has seen the motherboard of the particular system, right, you would have seen that there are specific slots for your RAM, right? There are specific slots and you can only fill those number of slots, right? You can't keep on adding more and more number of RAM to your system, right? That is the reason if you have one specific machine, you can just scale it vertically like till a specific point, okay? Right now, that is the reason. So when you talk about the typical big data use cases where it is all about storing the TBs of data, right? Where it is all about storing TBs of the data, definitely your transactional databases are not going to come into the picture, right? You need to go for some sort of distributed kind of database which can handle your use cases. Now, coming to the data analytical queries, right? So your transactional databases are not meant for the analytical, heavy analytical queries. What it means, let's say there are 10 users, 10 data analysts, and continuously they are running like complex queries, which includes multiple joins, multiple group bys, includes so many number of columns, and you are trying to do it on the table which you have created in these transactional databases, then obviously this is not going to give you the performance, right? And the reason is the storage type of it, right? The storage type of it, because in the transactional databases, we store the data in the row format. We will talk about it. I will give you the example of it. And this is the main blocker, right? This is the main blocker for this part, right? Because due to its nature of data storage, these type of transactional databases are not good fit for the heavy analytical queries, right? And you will understand this concept better when we will discuss bit about the columnar storage type, right? And why these NoSQL databases are good fit for the analytical queries as well. And your modern data warehouses, the best examples are your modern data warehouses like Redshift, Snowflake, all these things, right? So why we are able to run the queries so much fast on top of it using these type of warehouses and even on petabyte of data. So the reason is distribution, parallelization, storage, the columnar format, all those things are the major factor which are giving the good performance with respect to these data warehouses and the NoSQL databases. Okay. So vertical scalability not used for heavy data analytical queries. And important part is whatever queries you are performing here or whatever actions you are doing here, everything is a transaction, right? Everything is a transaction, and transactions basically have a specific life cycle, right? So whenever you start a transaction, okay, so it will have a specific life cycle, right? So maybe when you have initiated a particular action, right? So what your what these database application does, specifically the transactional databases, they will break it down the entire action into the smaller pieces, and everything will run based on the atomic transaction level, right? So here I will now focus more on the ACID properties and the data consistency and the row format part, right? And this will basically give you the clarity that for what type of use cases your transactional databases, right? Why we are basically saying that these are good fit for the like why these transactional databases like MySQL, Postgres are good fit for your use cases where you want the faster read write operation, you want to maintain the data consistency, and you will be getting the clarity from here. So right, so ACID property, A stands for atomicity. Your C for consistency. Data consistency is very much important. Third is your isolation. And four, D stands for durability. Okay. So atomicity, what it basically means when you are running a specific, you can say particular query on the database, right? As I said, it will broken down in the different it will be basically broken down, right? It will be broken down in the smaller segments, right? And that is what you can call the transaction. So here every, you can say transaction is atomic, right? Atomic means which you like after, when you have a specific query and you have broken down in the smaller pieces, so those are your atomic transactions, right? And it can be broken down further, and most important part here, right? Atomicity, each query action will be broken down. Each query action will be broken down as right atomic transaction, which will have a complete life cycle. Okay. And now coming to the consistency part. So this is something which is important because the main purpose of having the transactional databases into the system, that is maintaining the data consistency. Consistency means whenever you are performing a transaction, before that, right? Before that means whenever you are performing a specific transaction, before that, obviously your database should have been in a consistent state, and even after performing that transaction, its life cycle goes in such a way, right, that if your transaction was successful, right, then your database will be in the consistent state. Or if it is not able to complete, still somehow it should manage itself that the database in the consistent state, right? Let's try to understand it with a very basic example, right, of a, let's say, bank transaction something, right? Because the data consistency is something which is the main part of it. uh, right, so for an example here, you have a friend A, right? And this is the bank account of your friend A, and this is like A and B, two friends, and in his bank account 500 rupees, and in his bank account, let's say 600 rupees, correct? And we are talking about the banks here, so obviously this is data, right? This is the data, and this is maintained somewhere where in the databases, right? Now let's say you have the web applications, you have, let's say, phone pay, gpay, etc. And from here, right, what you did, you initiated some sort of action, and that action is, you are, let's say, A, so from your account you want to send 200 to the bank account B. Okay, send 200. Okay, this is the, you can say, action you are performing here. So this is the action which has been initiated now, and now there will be a backend application, right, which has captured this transaction. And ultimately, when you are doing a bank transaction, what is happening, there is an exchange of data, right? There isn't any exchange of money. This is the basically exchange of your data. Right? So now this database, right, this database needs to be updated. So your backend application has captured it, right? Whatever this transaction is going to happen. Now what will happen, this action will be transferred, because this action has to be performed on a specific database where the inventories are getting maintained, right? So now the transaction has been started. Okay, so send 200. Now we can call it like a, right, if you want to call it send 200, maybe just let's from A to B. I have elaborated it bit more. So this is one your action. Now let's simply break it down in the terms of actions, in the terms of transactions, right? I'm talking about the how things happens in the backend, right? And even if you are giving the query, or a query getting executed on a databases, how things are going to be broken down, right? Yes. So here you can deduct 200 from A, right? This is your first step. And here basically update value in account A to 300. After the deduction, it will have the 300. Similarly, uh, you can say add 200 to account B, update value of B, and then commit these changes. Right? So this is actually going to happen behind the scenes, right? The entire thing is going to be broken down on your transaction levels, like basically the atomic parts we were talking about. And after that, in whatever instructions are here, and this is applicable at most everywhere, even when you are writing a specific, let's say, Python program, right, to add two numbers. So what actually happened behind the scenes? So in your code, whatever you have written, like first read number A, then read number 2, and then perform the summation operation, and then print. So you have written four instructions sequentially, right? And it is going to get executed. So similarly, when you are performing that action or a query, it is getting broken down in the atomic level of transactions, which will get performed on these, you can say, particular data set, right? And each transaction will have the complete life cycle, right? Either it will get successful, right? Or it will come back to the previous state. And that is the technical definition of the data consistency, right? So data consistency in the transactional databases, what it means, that whenever a transaction is getting performed, right? So database will be in the consistent state after the completion of a transaction, right? Completion of a transaction, either it was successful or failure. There will be no intermediate state. There will be no intermediate state of a transaction, right? And we will understand it from here. So this is what going to happen, means before this transaction, right, before starting this transaction, what was the value, right, in account A and account B, 500, 600, means it was consistent. Consistence means there is no data discrepancy, right? Whatever maybe query or action you have performed after that one, right, whatever updated values should have been there, it is properly committed to your database, right? When this is happening means your data is getting consistent. It should not be like that at one place your value is X, right, and at some place your value has to be Y, but it is becoming Z. So this is your data inconsistency, right? It is not happening as per the rule, right? So before this action, this was the consistent state, right? So now if this particular like action, right, this particular action, if it goes in the successful state, right, and if something breaks in between, right, if something is breaks in between, it should be in the consistent state, right? So from here, minus 200, right, here it will be plus 200, right? After that, the updated value will become the, you can say, updated value will become 300 here, and updated value will become 800 here, right? So let's say this entire action is completed now, and after doing this thing, and you can see, right, this is the most important part. So there are two things, right? We will see these commands working properly. The commit and revoke, right? Commit and revoke. So what is the main purpose of this commit and revoke? Let's understand this one. So here, when we were performing this action, right, we broke it down in the atomic level of transactions, right? And when you actually work with the databases, right, when you actually work with the databases, then when these actions are getting performed, so what kind of, ultimately behind the scenes, what will happen, right? What type of operations you will be doing most of the time, right? what type of operations you will be doing? Insert, right? Insert means you are inserting a new entry, new record there. Update. If you have an existing record, you are updating it, right? So these are the three main operations you will be doing. Either a new get entry is getting inserted there or a particular existing value. So here what we are basically doing, we are doing the updates, right? In this particular action, right? Am I right or not here? What we are doing, we already had the account A, account B, and this action we are performing, which is simply updating the two accounts value, right? This is what we are doing. And then delete operation. Delete operation, let's say if now this B is not more the customer of account XY, bank XYZ. So if I want to delete the entry, we will be simply delete, right? Fire a delete command and it will remove the entry from the database, right? So these are the different operations we are doing. So there is a very important concept, right, in the databases, which basically helps in the durability part as well. The last concept, we will talk about it. And apart from that, what will happen? It also, you can say, helps in the recovery part, right? Helps in the data recovery part. So what actually happened? There is a concept of val, write ahead logs, right? Very important thing to talk about. So initially, when you initiated this particular action, right, we broken down in these specific, you can say, transactions, right? So initially, so whenever the entire action is broken down in these number of transactions, don't think that they will start getting executed immediately, right? Don't think that, or whatever, as soon as it is getting broken down and then these values will start updating. No, right? So this is more like cross check, right? So let's say you are playing a particular quiz, right? Your KBC sort of thing. So here the quiz master asks you multiple times, are you sure about it, right? Can we lock this option? Are you sure about it? All these things, right? And then finally it locks it, right? But if you see that 10-15 second window where that quiz master is asking you, right, are you sure, there everything has been already done, the entire processing has been done, because you, right, as a player have decided that okay, what is your final plan, what is the final option you will go for, right? But at the end that quiz master is just asking you, can we log this option or not, right? So maybe with that statement you can find it bit relatable. So when this action plan got created and the transactions, the particular steps will get executed, but final value of A and B, here after this update the value has to be 300, after this update value has to be 800, right? So these changes, right, these changes will not be reflecting until unless, right, you are performing the commit operation. So when you perform the commit operation, then any data related changes will be reflecting to your database, right? So by the time, right, until unless, so when these, you can say, transactions got created, so they will be, it will be considered as a temporary changes, right? So whatever you have done here, these will be considered as a temporary changes, right? And as soon as you perform the commit operation, right, you, as soon as you include the commit operation, then what will happen? right? So WAL, basically your temporary memory area where all these changes are getting written and getting computed. And as soon as you perform the commit operation, what it means that whatever changes, temporary changes we have done, now we need to make these changes as a final change, right? Final change, right? So from write ahead logs, this will be committed to the database memory. And now if you perform a query, what is the new value of account A and B, you will be getting 300 or 800. Let's say you have done all these temporary changes, right? And after doing this thing, you are not doing this part. You are not performing this statement. And if you write the query to find the amount in account A and account B, you will be getting 500 and 600. The reason is you have not committed your changes. So this is more like saving your file. Right, you have opened the notepad, you can write your entire code, right? So temporarily it is there for you, but as soon as you close it, right, you try to close it, it gives you the pop-up, right, save it or something, because if you don't do that, everything will be gone. So same thing happens here, right? So if you are not committing your changes, obviously, right, the final updated values will not be reflecting in the database. So data consistency part, this is what I said. Let me draw something here as well. Transaction will have two states. Success, fail. Okay. So there will be no intermediate state. There will be no intermediate state means, example, you initiated this plan. Obviously what happened that 200, right? The particular 200 value is something which has to be debited from the account A, right? And as soon as you did that, right? So the value of account A will try to become 300, and maybe in between there is a failure, right? In between there is, because of some technical glitch or anything, there is a failure, right? So in that case, what will happen? You will might see that the updated value of A is 300, but the new value of B is still 600, right? So what is this? This is data inconsistency, right? This is data inconsistency. So this is the main, you can say, theory of that in the ACID part, atomicity, and then second is the consistency. So as soon as a transaction is performed, before and after that, database has to be consistent, right? And for that one, either this entire transaction has to go in the successful state, means all the steps has to be executed correctly and the changes has to be made, right? But because of any reason, if the transaction is failed in between, right, in that case, the whole thing will be commit, and I think I have written this, sorry, my bad, not the commit and revoke, roll back, my bad. It has to be roll back, commit and roll back. Revoke is a basically you can say DCL command, okay, grant and revoke. So commit and roll back. So because of any intermediate step, right, let's say in the intermediate part your transaction is failing, so the entire thing has to be reverted back, and this is like rolling back. I'm rolling back to my previous consistent state, okay. And what was the previous consistent state? Where A was 500 and B was 600, right? So there will be no intermediate state of a transaction, right? By either successful or completely failed, right? Let's say at this particular point, right? This particular point, some sort of glitch happened, right? In that case, this this entire action will be rolled back to the previous point. Even before deducting, like here, all these things will be rolled back, because database has to be in the consistent state, right? It cannot be like 300 is only there and it is not becoming the, you can say 800, right? This is what your data consistency is. And this is the main important part. You will see transactional databases are getting used almost all such type of use cases where this type of strict consistency is needed, like your banking one, like banking systems. And apart from that, your let's say live ticket booking or anything where these type of consistencies are required, or any real world application where you have seen that everything is happening in a fraction of seconds and no data discrepancy is there, right? So you can definitely understand that some sort of transactional database is getting used behind the scenes, and that is why you are able to see all these things happening in the real time, right? So that is your data consistency part. And now coming to the I, which is isolation. So isolation is pretty simple to understand. So what is the main meaning of isolation in the real world? Isolation means even there are two folks, right? Both are them in the different room. They are completely isolated. What he is doing, they don't know about each other, and they are doing their own task. And this is the same theory of isolation in terms of this as well, right? So if you look at this part, here we had the multiple transactions. So what will happen if there is any transaction which can run in parallel, right? Or even all these transactions, they will run individually, right? And they don't know about each other, right? They don't know about each other, what he is doing, what he is doing. Whatever they are meant for, they will complete that process, but they do not care about what kind of value and which particular item this particular transaction is updating, deleting, inserting. Whatever he is supposed to do, he will do that, right, with its own life cycle. So this is your isolation. So in that case, right, in that case, what will happen, right? Whatever number of transactions can run in parallel, they will run in parallel. And also it helps to maintain the or it helps in the locking system as well, right? It actually helps in the locking system, because the database can lock the particular value as per the transaction initiated and all those things, right? Each transaction runs independently without knowing about other, right? So how you can, so this is basically can be understand in this way. 300, right? So imagine your database, and here there is a user A, and for this user A, the value of right, the total amount in his account is 300, right? So imagine there are two bank employees, right? Or I'm giving you the example, right? Just the example. There are two bank employees, or here you can say two concurrent operation, right? Two concurrent operation, right? Let's say this is transaction one, this is transaction two. So this transaction one, what it is trying to, so let's say this transaction, it initiated at exactly 10 a.m., right? And this transaction, it initiated at, let's say, 10th hour 0th minute and let's say 20th second AM, right? And this initiated at 30th second, correct? And what this transaction was doing, it was simply doing this part: read the value of A. And this transaction, what it is was doing, write, or maybe I can put it in this way, add 200 to A, which is basically your write operation, correct? Now, if you look at this entire box as a database where all these things are getting maintained, etc., right? So what is going to happen here? So if these two transactions are into the system, you can see based on their timestamp, right? Based on their timestamp, and here both T1 and T2 are trying to access the value of A, right? They are trying to access the value of A. So here, obviously, since they arrived into the system, uh, right? They arrived into the system on the different timestamp. Based on that, these values will be given, right? So obviously, there will be no data discrepancy, and maybe this operation will give the exact value like 300, and after this transaction the value will be updated to, let's say, 500. Now A will become 500. So this was the example where two transactions, one of read type and one of write type, right? But imagine this situation now, right? And this is exactly happened because whenever you try to think about the complexities of these transactional databases or databases, because don't imagine that only you are the one who is trying to access the particular record in the table, right? Because when you talk about the large scale of traffic, maybe thousands of users are trying to access the same thing, right? Imagine the live sale is going on Amazon's website, and at one particular point of time, one particular, let's say, 10th hour or something, there are 1000 users who have logged in, and everyone wants to buy the particular smartphone, right? So now imagine if, because let's say there are only 500 quantities, right? 500 quantities of that smartphone, 1000 users concurrently trying to add that particular item in their cart and completing the checkout process. So that value of quantity, basically that quantity of particular item, has to be updated in the real time, and it has to be, you can say, it has to be manipulated in the real time in such a way that there is no discrepancy, right? Example, when I am booking it, right? When I am booking it, the when I'm trying to purchase that particular smartphone, it is showing, let's say, 400 quantities, something, right? And maybe in the backend, all the quantity, like there are concurrent transactions are happening, and all the quantities of that smartphone have been sold out. And still, I am seeing the 400 value, means there is a data discrepancy. It is not, the entire database is not consistent, and I'm getting the wrong values, right? So this is the main part where all the transaction locking mechanism, the whole sophisticated part, which is more about like deep diving into the DBMS concept. But still, I want to talk about all these parts so that at least your concepts related to the transactional databases are clear. Although this was something which I did not supposed to teach, I simply wanted to start with the, let's say, SQL, writing the SQL queries, but this is fundamental. If this part is not clear, then why we are doing the commit operation, why we are doing the rollback operation, why insert, delete, update, how it is happening, row storage, then it will not make sense at all, right? So here, value of A 300. So now imagine this thing, the part which I was saying, T1, T2. Now imagine both T1 and T2, what they are doing here. Write x equals to x plus, not x, maybe a equals to a plus 200. And here what it will do, a equals to a minus 100, right? A minus 100 means this transaction here, someone is, let's say, transferring the value in this account, and here in this transaction this account is giving money to someone else. Okay, so this one again initiated at, let's say, 15th second, 17th second, right? So here now these two transactions, or even right, these two transactions, you can right, both are obviously independent, but what they are trying to do, they are trying to access the same, you can say, they are trying to access the same value here, same particular amount here. So in that case, will be a concept of the locking. Why locking is important? Because, right, this particular transaction was something which arrived 2 seconds before the T2, and even this particular transaction, right, might take couple of seconds to complete the whole process, like add 200 there, update the final value, and then committing the changes. It can take couple of seconds to complete the whole process, right? And let's say there was no locking mechanism. So what may happen, right? What may happen that, let's say, this transaction started, so 300, right? Let's say, imagine there was no particular locking mechanism, right? And these two transactions arrived and randomly they are getting executed, right? Randomly they started getting executed. So in that case, what could be the scenario here? Let's say before this one, this started getting executed. So what it will do? It will do 300 minus 100 something, okay, which will become 200. And then after that, 200 got added, right? So it will become 400. So for this transaction, whosoever, let's say there was user X, so he initiated this transaction, and before that, this user knew that the value in account A is 300. So if I am doing the right operation of 200, I should be getting the updated value of 500. After that, whatever happens, I don't care. But as per me, right, as per me, what I have done at that particular stage, I should be able to see this thing. This is what I am expecting, right? So, but if this is happening, right, if this is happening, both, let's say, are trying to update the value of item A at the same time, right? They started almost approx in parallel, right? So there are different type of locking mechanism as well, right? But here my main focus is to talk about the locking, that whenever there is a particular item and concurrent updates, so here we are writing means concurrent updates are happening, then locking mechanism will be there, which will try to handle all these transactions concurrency, which is, so this is the broader topic, the concurrency control. If concurrent updates, concurrent write operations on a same element are happening, then database behind the scenes will apply the concurrency mechanism, and including that one, the locking mechanism, so that transactions, right, can be executed in some specific sequence. And let's say this transaction has acquired the lock on value A, right? So in that case, this transaction will be put in a wait condition, until unless this is completed and release the lock, right? So this is the whole theory behind your locking mechanism and how concurrent updates are handled. And obviously, we talked about the isolation part. Last but not the least, your durability. So the part which I talked about, the write ahead logs, that is nothing, basically simply your durability, right? So yeah. So the part which we were talking about, the write ahead logs, right? Where first of all the changes are written into that temporary memory, right? And basically your volatile memory, right? So this is the durability part, which is basically for your data recovery. So here what you can understand, what you can say that the this will basically store your data, means any database will keep the data as long as it is in your volatile memory, right? And that time basically you can perform, right, both of the actions you can do, right? Either you can commit your final changes or you can basically roll back as well, right? Because there could be chances that let's say you initiated a particular update statement, right? So once you have done the update, if you have committed, means your changes will be done, but before the commit you realize that okay, you have executed the wrong command, right? So what you can do, you can simply just do the rollback. So whatever changes you have done, right, they will not be reflected and they will not be you can say finally pushed to the um database, right? So durability is all about like keeping your data and the data recovery part. So here your write ahead logs, because all the changes you are doing will be kept in the write ahead logs. So because of any reason, let's say some system crash or anything happens, so whatever changes you have done, right, it will be there, and once you restart the system, the changes can be taken forward from there, right? So that is all about your durability thing. Changes will be until committed or rollback. It will be kept. Hence, helpful in recovery in case of crash. Cool. So that was the ACID property, transactions, atomicity, all these parts. Database management DBMS, right? So what DBMS stands for? Your database management system, right? So DBMS stands for database management system, which So what is the technical definition of it? These are software application, as I said, software applications. These are software applications which helps to store and manipulate the data. Okay. So as I said, so you would have heard these terms. Let's install MySQL, right? Install MySQL where? So for that one, you need an environment. So when we say this thing, right? So let's say MongoDB, Cassandra, MySQL, Postgres, all these things, right? What they are? These are your software application, and you can name them like a DBMS, database management system, right? So when you say that a database management system, so database and DBMS, two different things. Database, right? That is a technical term, right? Technical term to mention that any system which stores or which just collects the data and store it in a particular format. That is your database. But when you say that DBMS, right? So we are talking about a application, software application. So MongoDB, Cassandra, MySQL, Postgres, what are these? These are basically your DBMS, database management system, which are allowing you to store the data. Plus, you can manipulate it. Manipulation is what means adding new, you can say data values, changing some existing values, deleting some values. So this is the manipulation part, right? So another term is the RDBMS, right? So RDBMS stands for relational relational database management system, right? So again these are software applications which helps to store data and manipulate data sets, will have relations, not have, may have, right? May have relations with each other and stores data in structured form. So we'll deep dive into the type of the data formats as well, right? So when we talk about the structured form, so whatever data you see in the Excel sheet, right? In the Excel sheet, you see your data, there are rows and columns, right? Or so this is what your structured data, and in the big data ecosystem, you would have heard three things: structured data, semi-structured data, and unstructured data, right? So quickly we can just talk about it, right? Three type of things, very simple to understand so that your terms are clear. Structured data, right? Structured data and semi-structured and unstructured. Okay. So structured data means data is stored in the row columnar format. Right. Semi-structured, you can say flexible schema. So here your example is like your CSV file or the Excel file, and you can say table in the MySQL, right? We will talk about it. And S flexible schema, so file formats like your JSON, XML, and unstructured means any such type of data which basically is not, probably you will not see, in most of the cases you will not see they are in the human readable form, right? For an example, your audio file, video file, you can definitely hear them, but let's say you try to open them in a notepad or something, you will see some jargons there, right? They are not in the human interpretable form. So no specific format. And even your data in the PDF file or something, if it's a complete textual data, right? What is that one? This is purely unstructured data. So no specific format. So example is your audio, video, PDF, etc. Okay. So RDBMS, these are again the software application which helps to store and manipulate the data and may have the relations with each other. These relations will be defined with the concept of primary keys and foreign keys, and stores data in the structured form, right? So that is the meaning of your RDBMS. Okay. So the part which I was talking about, whenever you will say that these DBMS, so imagine, right, what you will have, you will have a server, right? Or you can say a machine, or another example, you can understand it like a instance slash server on cloud, right? Because this is your environment. This is the machine where you can install the application and then you will make it executable, right? So setup RDBMS, right? So this is how the setup will look like, and this is how things actually work. Okay. So this is what your machine RDBMS. So the example of these relational databases, MySQL, these are different types of databases, right? And MS SQL means Microsoft SQL, and then we have Oracle, right? So these are your different type of relational database management system, or you can say your transactional databases, right? So MySQL, Postgres, MS SQL, Oracle, and many others, right? So what is the major difference between them? So again, like few of them are open source, few of them were developed by the organizations, right? So everyone definitely claims that this one is faster, this one is faster, this one is faster. So these type of comparisons you will see. Apart from that, there will be minor syntax changes as well. So MySQL, again, it's a software application which will follow the syntaxes, right? Right, syntaxes of writing the SQL queries, etc. Okay. Similarly, Postgres will also have MS, right? The Microsoft SQL or MySQL server basically has a different type of syntax as well. And similarly, Oracle has a different type of syntax, not completely different, but like declaring a function, right? And a few other relatable syntaxes might be different here and there, right? But in most of the systems, right? In most of the systems, the syntax which you will follow with the MySQL or Postgres, you will see this syntax is common across, right? Even if you are talking about the let's say data warehouses, Snowflake, Redshift, etc. So similar type of MySQL kind of syntax you can follow there. And when you will be working with Spark and its main component Spark SQL, right? So similarly, the syntax which you are following with either MySQL or Postgres type of transactional databases, that will be common there as well. Okay, and that is the reason. And even in the industry, you will see MySQL, Postgres are something which are widely used, right? So we will be moving ahead with the MySQL, right? We will the doing the setup part, and whatever query, whatever syntax, whatever SQL we will be covering in all these modules, right? That is following the syntax of you MySQL. Okay, so in the DBMS, RDBMS. So DBMS is the main category where you can put any sort of database, because most of them, right, all of them are the software applications which helps you to you can say store the data, manipulate the data. RDBMS means relational database management system. So here it stores the data in the specific structured format and will have the relations, right? So now from here, the part of MySQL will get started, right? So MySQL, what relations are basically the tables, right? So let me quickly draw, right? So let's say this is your employee table. So let's say name, age, salary, and team, right? So here, this is basically your table, right? This is going to be your table, right? And here, the first row or this first part which you are seeing here, these are basically your columns, or we also know them as the attributes. Basically, these will be defining the properties of that particular table as well. So these are your columns. This is basically your table, and we will be having, we can give the name to the particular table as well. And these are your rows, right? So these are your rows. So you can say like row 1, row 2, right? So rows are basically going to store your data in memory. Okay. So now after that one, so these are your rows. We have the columns, tables. So if you now want to understand the broader picture of it and how we are going to work with the MySQL, right? So this is how it will look like, right? So again, let me redraw it so that your thoughts are completely clear now that what is this, right? So here you can say this is your server, right? So after that, what you did, you installed MySQL application in it. right? MySQL database. Okay. MySQL RDBMS. I won't say only database. MySQL RDBMS. Right. Now, when you have the MySQL, okay, inside that one, you can create multiple databases. So let's say database 1, database 2, and each database can have multiple tables. Table 1, table 2, and this database can also have multiple tables. T1, T2, right? So this is how things will actually look like when you talk about any database application as a like complete or high level picture of it, right? So this is the thing, server application installed to that, we can create multiple databases into it, and each database can have multiple tables, right? And now, right, you can work with these type of MySQL. You can work with these type of databases. Okay. So now this is your MySQL application, which is running on some specific server. So obviously, if you want to interact with it, right? If you want to interact with it, what you need, right? Right? In order to interact with that one. So now you can basically interact with your MySQL in multiple ways, right? Programmatic, or you can say IDE based, right? So programmatic means if you have your MySQL, right, and right, this is an application. So here it will have some sort of credentials, right? Whenever you want to connect with any machine or even anything, right? What you need the login username and the password for that one. So programmatic. So what you can do that here for the programmatic part, right? So programmatic here means any Python, Java, etc. program which needs some library, right? Which needs some library to connect and work with MySQL, right? So in that case, let's say example MySQL connector, right? So this is a Python based library. So if you want to write a Python program to programmatically execute queries on MySQL, right? So what you will do, you will write a Python program. You need the support, right? You need the support of what? You need the support of uh, you can say some libraries, so that you can make a connection to MySQL and you can work with that one, right? Apart from that, the workbench kind of thing or some sort of UI based interface which helps you to write these type of queries and execute it from there. But again, right, what you need to do, you need to make a connection. You need to make a connection with your MySQL or whatever database you have installed. First set up that connection, and then from that UI interface you will be able to run your queries. Okay, so IDE/workbench. So after all these things, I hope you are able to understand, right, what we are doing so far and what we uh, why we need this workbench or something. I hope you are getting the clarity now that what we are going to use it for. So workbench is what? So MySQL workbench is one of the example, right? So that is another application simply, right? That is another application which also comes with a instance, which also comes with a MySQL instance in your local machine. For an example, I want to practice the MySQL, right? The queries, everything or something. So here, as I said, what you need? First of all, you need a machine where you will first set up a MySQL and then will start performing the queries, right? So here you can imagine that you don't have a separate server, you don't have a separate MySQL. So when you set up your MySQL workbench in your system, right, what it does, it basically spins up a tiny MySQL instance for you as well, right? And for that one, right, in the beginning, you will set up a root username, root password. That is the login username and password for the local MySQL instance, which is running along with your MySQL workbench, right? Now there will be, here I can quickly wrap it up. Just a moment. Yeah. Running queries from UI interface. Okay, so here for the example, let's say you have this thing. When you are setting up the MySQL workbench, this is your entire workbench. So what it will do, once you are setting it up, it will MySQL instance. It will spin up a local MySQL instance for you, right? And here what you need to do, create connection. So you will create a connection here, MySQL instance, and as soon as in your workbench you connect with this instance, it will start working, right? Now similarly you can consider it in this way as well, right? So quickly, for example, now imagine that you have this MySQL instance at some remote location, maybe on cloud, right? So your database is on the cloud, but you want to run some queries on top of it, right? So in that case, what you can do, you can again, like similarly, have the MySQL workbench in your system. Right? And here you can simply create connection. And here is your remote MySQL. You know the login username and password for it. Create connection here. Right? So now your MySQL workbench is connected with that remote MySQL. So whatever queries you are typing on your MySQL workbench UI and executing it, all those queries are executing on this one, right? So this is how your MySQL workbench is going to help you here. Got it? So now that's pretty much for all that theoretical part. Now let's jump into our main practical thing, and let's get started with that one. So this was the part, right? In the beginning, I mentioned you all that you all need to install the MySQL workbench as well. And I also gave you some, what I should say, I gave you some references for that one, how you can do that, right? Or MySQL workbench, let's say in Mac, right? So this is how simply you need to search. You will obviously find multiple video references. So any of the good reference you can follow. And this is going to be the official website, right? MySQL Workbench manual installation, right? So this is the kind of interface, like this is the kind of uh, page you will see steps. Ultimately, you need to go here, download Workbench, right? Download that particular file, the DMG file. So let me click on it. So here you will see that, right? From here, you can select the specific operating system. I have a Mac OS. Let's say if you have a Microsoft Windows, so you can pick that one and you can install the MySQL Workbench, right? You will see these files, the DMG file, download that one and simply just start clicking on it. Very like the way you install other application, let's say VLC media player or anything in your Windows or something, it is just similar to that one, right? And maybe in Windows you might get the tar file or .exe file. Just do that, and similarly for Mac you can install it. Very easy installation steps. And as I said, I have already shared the video references. You will find it in your dashboard, or you can quickly go through any of it and you can install MySQL Workbench in your system. This is the part I was talking about. As soon as your MySQL Workbench, let's say, is installed properly. So first thing, obviously, it will spin up the local MySQL instance as well. For that one, you will be setting up the username and password during the installation part of it, which is basically your root username and password, whatever it is. And after that, you can see, right? If you want to connect your MySQL workbench with that local MySQL instance, right, which is coming along with your workbench. So from here, you need to make a connection, right? You will see this plus sign here, right? And again, let's say I have a MySQL instance on a remote location and I want to connect MySQL workbench with that one. So you can create a connection from here as well. So this plus sign, this kind of window you will see here. So you can give a connection name. Let's say MySQL on AWS dev, right? So I have a development I have AWS account, which I use, let's say, for the development, and I have a MySQL installed there. So simply, this is the name I have given. So host name, obviously your MySQL application is installed on some specific server. So that is specific server, or specifically your MySQL will have a specific URL, right? So you need to provide that host URL and some port as well, because each software application, right? So it's server, or it is always binded with a specific port. So it will be listening the request on a specific port. So provide that port, and you need to provide the username and password for it. Like whatever username and password you can use to log in into that MySQL, right? So provide the username, and here click on this store in keychain and provide the password here, right? And once you do that, from here you can simply test the connection and click OK. And after that, this is how the connection will get created, right? Your connection will be there. Now, if you want to basically want to get connected with that particular, you will see this kind of interface will be in front of you, right? Where in the left hand side, you will be seeing the databases. So, right, the diagram which I showed you, where in the MySQL, you can create multiple databases. Each database will have different tables. So on the left hand side, whatever you are seeing with this database icon means it is your database. And if I click on it, so here you will see multiple categories. So we will talk about views, stored procedure functions on later part. But as I said, in a database, you will be having multiple tables. You can create multiple tables. So you will see right? There is a tables category, and inside that one, right? So if you have gone through with that basics of the Docker, so you can simply download the Docker file, Docker compose file, Docker image for the MySQL, and you can simply run the particular Docker file, and in your local MySQL will be installed, and you can simply practice it on the command line. That is also you can do. So in order to do that, first you need to make sure that you have a Docker desktop installed, right? So this is the alternate operation. This is the alternate I am talking about. Both of the things are not mandatory, as I am saying, right? It is just the alternate for you if you want to do that. Right. So let me quickly show you that how this Docker compose file will look like. Right. So this is your Docker compose file. I will be sharing this Docker compose file. What it does, it includes the Docker image of MySQL, and here the password, the root, the username is admin and the password is admin. And here you can see it will be starting on this particular port, right? So this is how you can simply start the MySQL in your local. And how to do that, I will quickly tell you. Let me open the terminal and I will simply run it from there. I will run this Docker compose file. But for this one, this option is an alternate. I'm showing it as an alternate operation. If you have gone through with the Docker basics, because Docker basics are required for it. In case if you don't want to go with this route, you can simply look for the workbench part, which I was talking about. That will suffice everything. Okay. So Docker PS. All right. Now desktop TE. So command to run the Docker compose file. So Docker compose -f MySQL Docker YAML up-d. Right. So now you can see that this MySQL thing, the Docker container for MySQL is running in my system, and I can simply click on it. And here I can go to terminal. Let's type MySQL -u. Cool. You can see I have just started the MySQL terminal. Okay. What I followed? Nothing. Uh, I simply first installed the Docker desktop in my system, and after that I had the Docker compose file for the MySQL. And with the help of Docker compose file, I started the container for MySQL in my system, right? And then again, I can quickly come back and show you this step. So you will see your MySQL container is running, and it is using the image of MySQL. And I can simply click on it. You will see the logs, and you can, from here, you can go to the terminal. Let me do the exit once. And let me, okay, show you this again. So, right, how you can simply log in into the MySQL here. What was the login? Username was admin and password was admin. Okay. So same thing I followed here as well. So if you look at this part, okay, what I will do from the command line, if I have to open the MySQL shell so that I can practice the commands from the terminal. So MySQL -u for user, you need to provide the username, which was admin, -p switch for password. So just type -p and hit enter, and it will ask you for the password. And in the Docker Compose, as I showed you, the password is also admin. So admin and hit enter. Now you can see you are basically accessing the MySQL shell. So now if I run other commands like show databases, I will show you all these commands. So you can see this is how it will look like, and you can practice whatever commands. Let's say I will be writing on the MySQL workbench, same exactly, right? You can type it on the MySQL shell and you can practice it from here. In case you can set it up if you wish to. And before that, make sure either Docker is installed in your system, and best is Docker desktop. Both, right? You need to have in your system, and then you will be able to run this Docker part as well. Okay. So since I don't need this one, I will the basic commands of it. And before that one, let me quickly show you these things as well. That what, so I will be sharing this presentation part as well, right? Which you can follow. Most used DBMS, right? These are there, and I have written the like highlighted points here which you can refer for like anytime, just to go through as a quick notes. So I will be sharing these notes with you along with the rough notes which I created. So all the theories like the RDBMS, DBMS, we have already gone through it. And for the SQL part, right, stands for structured query language, helps you to interact with your database, because right, if you want to even write some code, you need the support of programming language so that you can interact with the machine. Similarly, MySQL, right, is another software application. So if you want to interact with the MySQL and you want to work with the data, what you need the support of some query language, right? So that is the things what you can do with the SQL. And before the data types, this is the main important part, right? This is the main important part which we need to follow. And throughout all our SQL practice part, we will be running queries around these specific commands, right? So in the SQL, or basically we talk about the MySQL and the RDBMS. So the SQL is actually categorized in the four parts: the DDL, DML, DQL, DCL, right? So DDL stands for data definition language, right? So any specific SQL command, which, because earlier I explained there is a concept of table, right? So table, it will have columns, right? And it will have the rows and columns, right? Columns are what? Columns are like the attributes and properties specifically, right? Now, one more example. Let's say you are writing a Python program to add two numbers, right? To add two numbers. So imagine one number could be of integer and another number could be of decimal. So here in the programming language specifically, we can say that variables will have the data types, because in a variable you can have a integer value, decimal value, string type of value, array value, and apart from that some struct, right, which is storing the heterogeneous kind of data. So different types of values you can have in a variable, right? So similarly, in your table you have rows and columns. So columns are what? Columns are the attributes, and each column will have a data type as well, right? So for an example, you have a column and its name is first name, another column last name. So both of the columns, right, will be storing string kind of data, only the characters part, right? And there could be a column named as, let's say, salary, which could be of integer type or could be of decimal type, right? And there is another column named as percentage hike, percentage salary hike. So it can also be of integer and decimal type. So when you create a table, inside that one, you will be creating the different columns with different data types, right? So when we talk about creating a table, means we are defining it, right? Let's say I have created an employee table, and in the beginning I mentioned it will have 4 columns, right? So 4 columns, each column may have a different data type. So what we can say, this process, we can say that we have defined the structure of our table. So any SQL command which will put a direct impact on the structure or the definition of a table, that will be put under the DDL, means data definition language. So create is one SQL command, alter, drop, truncate, and rename. We will be looking right all the examples, so don't worry. So DDL means these are the command. Create. So if I'm creating a new table, what does it mean? I am defining it, or I am defining a new structure. So I am directly impacting the structure of a table. So this is your DDL. Now DML, data manipulation language. So data manipulation means any SQL command, right, which will directly manipulate the data stored in that particular table, that will fall under the DML. So insert, if I am inserting a new row or new data point, means this is manipulation. If I am updating existing value, this is a manipulation. If I am deleting a particular record or a row, this is also data manipulation. Now coming to the DQL part, data query language. So now let's say you have the data inside a table. How you are going to fetch that one? Fetch means like you can do multiple operation, right? For an example, you have a data of sales, right? So you are interested to look at the total sale you have made on 1st of June, right? So you have the data and now you want to fetch this result. So in order to fetch this result, you need to perform a query. And for that one, you need to follow the select command, which is the DQL. Query means for fetching the results. Now the DCL part, data control language, means grant and revoke, right? So for an example, like we created a blue box of MySQL server, and inside that one we have a MySQL application installed, then databases, then multiple tables inside that one, right? So when you work in an organization, there could be, let's say, multiple developers, and each developer might be assigned a different task to work with different data sets, right? Or maybe with the same data set, right? So now imagine data is something which is very critical, very crucial, right? So in our database, let's say we are storing the credit card information of the customers. So this is highly sensitive information. Let's say along with that one, phone number and email ID, address, these are highly sensitive information. Okay. So there are multiple developers. So it's not necessary that all other developers need to have the access on these highly sensitive table data, right? It is not necessary. Or let's say there is a new intern, right? Let's say there is a new intern which has joined your team. So now you have a very critical table which stores the critical data. And we all know that we can perform the insert, update, delete, all these type of operations on a particular table. So would you like to give that intern insert, update, delete operations access in the very beginning? As a, let's say, team lead, would you like to do that? In the very beginning, you have given insert, update, delete all such type of access on that particular table, right? Absolutely not, because you don't know, maybe by mistake he can drop the table, right? He can delete some records, he can insert some random records. Okay. So how you are going to control these type of access, right? How you are going to control these type of permissions? So for that one, we have a grant command in the SQL. Based on this grant command, I can define what kind of permission this user will have. Either he can run the select command, alter command, drop command, truncate command, delete command, insert command, whatever. What kind of actions this particular user can perform. So in order to handle these type of permissions, we can use the grant command. Similarly, earlier, if we given some type of permissions and I want to revoke that one, then I can simply revoke. I can use the revoke command, and you this is also fall under the DCL, and you can take those permissions out, right? So this is the main you can part of the whole categorization of the different SQL commands, right? So now coming to this part, I was talking about the data types. So I have listed down the data types here, that when you are basically creating a table, so different types of data, different kind of data types will be there. So here you can see string data type, which can be defined with char, nchar, where char, right? Similarly, if there is a column which is of data type, so you have this data type, date time, timestamp. And similarly, if you have any particular column which stores data in the true and false form, so boolean, similarly integer, float, double, decimal. So these are different data types which you will keep on looking and understanding as soon as we start creating some type of you can say tables and data inside that one. So now this is the basic part I wanted to tell you. Now let's come here and let's start with the very first thing. So first thing is how we can create the database, right? Or let's say now you have logged in into the you have set up a connection with your remote MySQL, right? And you want to see how many databases are there which are already created, right? Which are already existing. So what kind of command we can follow, right? So in the MySQL workbench, right, if you want to make any specific line as a comment, so you can simply put two double hyphens, right? Two double hyphens in that in front of that line, and it will become a comment, right? So this will be a comment in the MySQL workbench. Now here, let's say I want, as I said, I want to see how many databases, which you can see on the left hand side, how many databases are already created. So I can run the command show databases. Now the question is how to run the query on MySQL workbench, right? So simply what you need to do, you need to just select that particular query completely. And here you will see this icon, thunder icon, right? So just click on that one and you can see right here. So fonting will be bit low, at least with the, what I should say, MySQL workbench interface here. So you can see you are getting the output result here. So on the left hand side, you will not see some you can say system generated databases, right? So on the left hand side, you can see the sys and temp db. But when you ran this one, show databases, you are getting list of 5 databases: information schema, MySQL, performance schema, sys, temp db. So performance schema, MySQL, information schema, sys, these are basically metadata related databases which MySQL workbench itself creates during the installation part, right? These are system related databases which are hidden from the users. So these are the number of databases which are available here. So this is the command to see the list of databases. Now, if I want to create an empty database so that I can start creating the new tables inside that one. So how we can do that? So for that one, you have this command. You can simply follow this command. This is a command to create the database. So create database. Let's say this is a db noob underscore db. I have created. So how to run this command, and after running this command, what will happen? So just select this one and this create database noob db, you can see, right, the result, it has been created. And let's say because of any reason it was failing, then you will see the reason of failure here as well. But now your question would be, if we have created the database, why it is not reflecting on the left hand side? It has to be. Okay. So here you need to click on this refresh sign, right? Here I'm pointing the arrow. You will see a very small refresh arrow circle type of icon. So just click on this so that your left hand side will be refreshed, right? Now you can see my database which I have created. It is present on the left hand side. Okay. Now, if you click on it, you will see category like tables, views, SP functions. So at this moment, everything is empty because this is the first database we are creating, and we don't have we did not create any specific table, views, SP and other things inside this one. Cool. So let's take a quick 3-4 minute of break and then we will continue. All right, so let's meet at 11:15 or 11:16. Okay. I can see a comment, schema and DB is same here. Yes, schema and database is the similar term with respect to the MySQL Workbench. Let's get started. And guys, it's not a voice issue or I'm not audible. I'm not sure whether you hear me or not. I already told you that it's a break for 4 or 5 minutes. So when it's a break, right, I won't be speaking anything, right? I won't be turning on my video, but yeah, I can reply to the chat or etc. Right? So just uh, keep on hearing me what I said, right? Cool. So maybe I can just answer one and two things specifically related to the confusion of schema and database. So see, don't get confused by this term named as schema, because this is a more specific or in general terms you will see across different databases, different data warehouses, right? Right. So this is a you can simply relate that one on different IDs level as well. You will see these differences, right? At some IDs, you will see that this section is named as schema. In some IDs, you will see that this section is named as the database, right? So don't get confused with that one. I know it is bit confusing because there are two references for the schema, because when we will be creating a table and we are defining the columns, that is also creating the schema, right? And here when it is mentioned the schema, that is why it's get confusing. So whatever is so for your basic and simple understanding, just replace this schema part with the database name, as simple as that one. And whatever we are writing while creating the table, right? Whatever we are providing during the create table command, that is basically defining the schema. Okay. So I hope now there shouldn't be any confusion why this is a schema and not a database. It will keep on differentiating if you go with different IDs and different data warehouses and their interfaces. You will see this is happening. Cool. So we created a database. Now, after creating a database, right? As you can see on the left hand side, there are multiple databases. And now I want to create a table. But how this MySQL workbench or whatever, let's say create table command I am writing, how this will get to know that inside which particular database I need to create the table, right? So there are two ways of it. Okay. So let's say you have created a database or you have an existing database, and now you only want to work with the tables inside that database. So it's better to go inside that database. And once you are inside the database, whatever commands you are writing, whatever tables you are accessing, right? It is already present there and you can run the queries on top of it without any challenge. Okay. So for that one, what you can do, you can run this command. Command to get inside a database. So use noob underscore db means what I'm trying to do here, I am trying to go inside this particular database. So just select this one and click on it. And now I am inside this particular database, right? And it will get highlighted as well, right? You can see as soon as you do that on the left hand side, it's bit highlighted and bold one. Okay. So now cool, we are inside this one, and this is now the time is to create some table. Okay. So for an example, if I want to create a table inside a database, then what we need to do, right? We need to follow the DDL, data definition, means any such type of command which falls under the DDL so that we can use it. Okay. So let's do that. Okay. So command to create a table. This is a very basic command, right? This is a very basic table I am creating here. Okay. So here, in order to create a table, how the syntax will look like. So create table and this keyword, right? This keyword is basically to handle the failure part. Failure part, because imagine this is your, right? This is your, what I should say, database. Okay. Now you are inside this one, and maybe you do not know that this employee table already exists. Okay. So in that case, you only want to execute this command if this table does not exist. Okay. This does not exist. So here, what I'm doing, create table, if not exist, this is the table name. And after that, what I'm doing here, we are simply defining the column name. So this is the column name ID, and this is the column name employee name. And for each column name, as I have different type of data types in MySQL, so type, we followed data type integer, right? ID like 1, 2, 3, 4, 5 employee ID. So I am giving a data type integer here, and you can see what kind of values it can handle, right? A name, employee name, I am following the varchar, and in the bracket, I have written some number. Okay. So here, what is varchar? You can see string data types in MySQL. So data type char, nchar, varchar, varchar bracket n. This syntax means it stores approximately n characters. So varchar, char, these type of data types basically to define any column which will be holding the string type of values. Okay. And in the bracket, I have written 20 or some specific integer number. So what it means, the employee name can only handle at max 20 characters. If I am trying to insert any row where employee name is having, let's say, 21 character to 23, 30, 40, 50, then we will not be able to insert that record because it is violating the structure and the definition of my table. Getting the point? So this is how the basic syntax of create table looks like in the MySQL. So create table, and what is this command and in which category this is following? This is falling under the DDL. We are defining the blueprint or the structure of our table, right? And in general, right? In general, what you will see that this part is known as the schema, right? Schema means whenever you are defining the structure, you are creating the schema of it, right? This is the main in general reference you will see, and whatever is listed here, this will always be known as the database. Got it? So now let's say we have created a table. Okay. And imagine there could be some existing tables, right? Let's say this noob was already created, right? Already created. Then what we will be doing, right? If it was already created and we want to list down how many tables are already created. Okay. How many tables are already created? Then the way we ran this command, show databases, we can also run show this thing, show tables. Okay. I can see one comment, what is 20 inside that bracket? So, okay, Ajinkya, maybe just a question for you. Are you listening the whole conversation carefully, or you are intermediately listening or watching the recording? Just want to know like how attentive you are throughout the live class. Because just before your comment, maybe I explained it thoroughly that what so taking notes and listening, please don't do that. Don't do that. All these commands I will be providing. The PPT I will be providing. The rough notes I will be providing. By the time I am explaining things in the class, I want you to be attentive on the screen. If you have maybe downloaded the MySQL workbench, that is fine, right? You can practice all these things after the class, but by the time I'm explaining, I want all of you to be attentive here. Got it? So that would be helpful, and that's a request from my side to all of you, because in that case you might miss a very important thing, right? Let's say I'm saying some important interview question, I'm narrating it, I'm explaining it, how to answer it, and while taking the notes, you can miss that thing, right? So it's important, and don't worry about all these things. I will be providing you. Cool. Now I was talking about command to see the list of tables. Okay. So show tables, show databases. It gave us the list of the databases. Now, since we are inside a database, if we want to see how many tables are created there, I can simply run this command, show tables. So click on it and you can see. Wait. Tables. Oh, I think I forgot use noobdb. Oh, I did not run this command. I did not run the create table command. Okay, okay, yeah. So now, yeah, I have created this one. So now our table is created. So I can simply refresh it and you can see that the employee table is created here. And if I expand it, and you will see a lot of things here, like the columns, list, and all those things. And after that, when I am running this thing, show tables, right, then you will see that list tables in the new DB database, and the table name is employee. Okay. And here it is not case sensitive, right? So you can write completely in the capitals. You can use the small letters. You can even use the mix of both capital and small letters. It is not case sensitive. Okay. So show tables. And as I said, here the table is created now. So now the next thing, what we will be doing. So for an example, let's say there is a table, right? For an example, let's say there is a table which was already created. Okay. Let's say there is a table which is already created and you want to, right? And you want to check the definition of it. Definition of it, maybe you want to copy the complete create table command of it, because here we wrote the create table command, we executed it, and we saw that table is created, and we ran the show tables and it gave us the list of it. Imagine, right? Imagine if we want to see the create table, or if we want to see the definition of existing table, in that case, what we need to do, right? In that case, we can run this command, right? And it will help us to give the create table definition, right? Create table command of any table. So here, show create table employee, right? So if I run this thing, okay. So if you see the output, right? In the output, what I am getting, I'm getting two columns, table name is employee, and another column create table. So you can see I am getting the complete create table command. Means if somebody would have created this table, that time whatever create table command was used, right, I am able to fetch it. And with this command, show create table and the table name. This is how you can get the definition of a particular table. All right. Now let's create one more table with few more columns, maybe 2-3 columns, and then we will try to operate on it. Okay. So here I have similar to employee table, and what I have named it employee underscore v1. So here I have one column named as ID and data type integer, and here column name is name. Varchar means maximum 50 character it can have. Salary, a double means it can have a float value, mean along with the decimal. Hiring date means this will follow a date data type, means YYY hyphen MM hyphen DD. This kind of date format it will follow. So let's execute this one. So this table is also created. And now let's look at the DML part. Means we have the empty table. Okay. So we will be looking at the different kind of syntaxes, right? We will be looking at the different kind of syntaxes with respect to the table data insertion. Okay. So let's look at that part. So how we can insert that one? Let's look at it. So this is your syntax one. So how the data we will be inserting manually, let's say with the help of DML commands, data manipulation language. So the syntax is going to be, I will be talking about multiple syntaxes. So just hold on and see how it is going to look like. So insert into, then the table name and values. So let's say I only want to insert one record at a time. Then this is the kind of syntax you can follow, right? Insert into table name values. And in my table structure, these are the columns sequentially I am following: ID, name, salary, hiring date, right? So ID, name, salary, and then hiring date. This is a sequence of column in my table. So now when I'm inserting this particular row, right? So the values which I will be providing inside this values bracket, it should follow the same sequence, right? Else, right, this insert command will fail because of any reason. And I will show you that reason, what can happen. Okay. So here insert into employee v1 values. So ID is 1, name is Shashank, salary is let's say 1000, and hiring date is this one. Okay. So now if I'm running this thing, okay, so you can see the insert into command is successful. Correct. Data is inserted. And now after this one, right, I will run one more command, right? Let's say this thing. Right, let me execute it. So I have executed it, and in the bottom you can see that this command, this insert command which I have run, it is failed. So can anyone explain that why this insert command is failing? Right? So absolutely, I'm getting the right answers because this is a data type mismatch. Because if you look at the sequence of column you have created, so first is ID, which is expecting the integer value, then name, then salary, then hiring date. So when I ran this insert command, so I gave first value as an integer, which is getting inside the ID column. Then Shashank, right, which gave in which was part of name column. Then 1000, part of salary, and then this is your date column. So date column also follows this string type of you can say structure, but the default date format, if you are not giving this YYY hyphen MM hyphen DD, or let's say here inside this one I am writing Amit and I'm trying to store it in the hiring date, your insert command will fail because I have defined it as a date data type. So it is specifically looking the date format of YYY hyphen MM hyphen DD. So I have put it in a single quote, and this is how you insert the value in the date type of column. It will follow the quotes, but inside that one proper date format should be there. It can't be like that any random string value you are putting in the hiring date column, right? And here what I did something with the sequencing of the values. So first value I am putting as a Shashank, which will try to go inside ID column, and ID is expecting int, but I am passing a string value. Obviously it's a data type match, so it will fail. Correct? Cool. Now the next syntax, and maybe I'm writing this next query and you need to now tell me the answer, what will happen. So I have written this thing and I'm trying to execute it. What will happen here? Right? This will also fail. Right? This will also fail. Let's try to run it. Because when you're trying to insert the data inside the particular table, so obviously the definition or the structure of the table will matter a lot. And apart from that, in order to maintain the data consistency, one another thing is important, and that is the integrity constraint, right? The integrity constraint, that is also one important thing which we will be talking about dedicatedly, that how it can impact the things. So integrity constraint is something which will help you to maintain your data consistently in the table. For an example, this salary, right? So obviously it's quite obvious that you would not have hired any employee without assigning some salary. But by any chance, there is multiple records in the table where this salary column is having the empty values, means it does not have any salary value, right? So is it the expected behavior for your table, or would you like to have your employee table follow this kind of format where salary column is becoming empty? Absolutely not. You would like to you would like to put some kind of constraint, right? Means, let's say there is a user who is trying to insert a new row, and by any chance or by default he is making that salary column as empty or null and trying to insert it. So I will apply some kind of check on this salary column, and that check could be like not null. That is just one example of integrity constraint. So integrity constraint means to maintain the consistency, right? So now if I write something like salary and then its data type and not null as an integrity constraint. So if I am trying to insert any data inside this table where salary is coming as null, it will fail because I have put some sort of constraint. So we'll look into that one. But here this one will fail because obviously what is happening in our table structure, right? In our table structure, what is happening that it will expect the four values. And also if you look at the sequence, first is one, means ID, second is name, third has to be the salary, right? But the third column, we are putting it like a string or a date format, which is trying to get inside the salary column. And obviously, because of that data type mismatch, this will fail. Correct? Now let's look at the let's look at this part where if we want to insert the data in some specific column, because here one challenge, right? If you are trying to follow this syntax, there is one challenge, and that challenge is what? Can anyone tell what challenge is that one? The challenge is basically to remember the sequence of columns, or to just strictly remember and follow the sequence of these values as per the sequence of columns in the schema. That is the challenge. What if I have 50 columns, right? What if I have 50 columns in my table and the data or the record I am inserting, I only have to populate 8 columns, rest 42 can be completely empty, and I don't want to insert any value for that one. Correct? So in that case, and also I don't want to bother about the specific sequence of these values, right? So how we can do that? In that case, this kind of syntax can be followed, right? So here, this is your second syntax. So if you look at this part, you can see what I am doing. Insert into, then table name, and in the bracket, I am giving some column names. So you can see in my table structure, ID, name, salary, hiring date. But here in the bracket, randomly, I have given this thing, salary, and then name, and then ID. Okay. So here I have given column name, and I have defined my, in this way, I have defined my own sequence, let's say. Okay. So now you can say that here 4 columns were needed, but now since, so now if you look at this employee, and if we are not giving any specific columns, so by default, what it is considering? It is considering all the columns, right? That is why this command was able to execute, right? But if you are putting the insert command in this way, means it is only looking for these columns, means the values which we will be providing in this values parenthesis, it will be only for this part. Okay. So salary means in the values part, the first value I have to provide for the salary, then name, then ID, right? And now let's execute this one. So I have executed it, and at the bottom you can see this is executed and successfully inserted. Okay. Now, so far what we tried to did, we tried to insert one record at a time. Okay. Now, let's say if we want to insert maybe multiple records with one single insert command. So how we can do that, right? So for that one, we can follow this part, this syntax. Okay. Cool. So in this way, if we want to insert multiple records, what you can do, insert into table name, values in the bracket, your one record, and then comma separated. There is no need to write the values again. Simply another record and then comma, then your third record, right? So in this way, within one single insert command, you can add multiple records. So let's execute it, and you can see this statement is also executed. Got it? So far we have basically followed different syntaxes, and now let's say you have inserted some data, right? You have inserted some data. Okay. So in that case, what is happening, right? If we want to, let's say, look at the data which we have inserted. So for that one, we can follow the DQL part, means the select query. Okay. So for that one, you just need to run this select query, and we will look different syntaxes of it as well, like how to fetch the results with a specific number of columns, apply some operations in the select statement. But here, understand this basic part. Let's say you want to just fetch all the data from that specific table, and you want to see all the columns. So you need to simply write this command, select star from this table. So star represents all the columns, right? From this table, I want to fetch all the columns. So just select this one and execute it. And now you can see in your output, right? You are getting all the data which you have inserted so far, right? Cool. Now, so far, since we have executed multiple insert command, so anyone having doubt specifically to the insert, because I have a particular doubt, because maybe so far nobody asked this question, that insert, delete, update, right? These will be written into the write ahead logs, correct? So why we are saying that, like Shashank, you simply ran the insert command, okay? And after that, when you ran the select command, you are able to see all the records. But when you are teaching the theory, you said, right, when these actions like insert, update, delete, right, what will happen, right? In that case, you need to explicitly commit those changes, okay, so that these final changes are there. So the reason is, in MySQL workbench, right, in MySQL workbench, there is auto commit, right? So you will probably see query editor. Where was that setting? SQL execution. You can see, right? You can see in the settings of the SQL editor, new connections use auto commit mode, right? So auto commit mode means as soon as I am performing these type of operations like insert, update, delete, etc. So as soon as I am doing it, the changes are getting directly committed to the table. But let's say if I have disabled this option, all right, you can definitely try this, right? So here in the preferences, you can find the SQL execution, create the new connection or anything, and just simply maybe disable this property and try to execute the insert command, delete command or anything. And after that, you will see that your changes are not getting committed until unless you run the commit command explicitly. So how you will be running the commit command explicitly? Let's say I wrote this insert command. After that, I simply need to do this thing, commit semicolon, select this and run. So whatever updates or whatever, let's say, changes you have been doing so far in your query editor, right? Everything will get reflected in your table. Once a transaction is committed, it cannot be rolled back, right? But before committing your changes, let's say you were making, so obviously first for that one, your auto commit has to be disabled. And maybe by any chance, let's say accidentally you have deleted, let's say your auto commit is disabled and there is a table, you have run the delete command and now every data is gone. If you run the select command, maybe you will not see anything, right, for that particular moment, for that particular instance. But that is not going to be the case. If you feel that you have ran the update command or something by mistake, changes are yet not committed and you would like to roll back, so you can simply run the rollback, so that these intermediate update steps which are written in the write ahead logs, they will be taken out, right? If you are committing it or maybe you commit it at the later point of time, then obviously the previous updates you have done, those will be also considered. But if you have committed any change, then obviously it cannot be rolled back.